You can talk about review stuff. You can talk about anything and all of it. I'm fair game, open book, or do whatever. Paul?
Can you do number 4 from the problems? Like you're able to simplify it.
Yeah.
I wasn't.
Okay. So 4. Well, we did this. I did this with everybody. I don't remember what I did, to be honest, on the key. But we did this in 5th hour, and I started by doing trig identities here. I didn't really make it much easier. Yeah, I got it to turn into like cosecant squared times secant, which is a product and a chain rather than just being a quotient, which I think is 6 of one, half dozen of the other. So I don't think there's anything wrong if you just approach this as a quotient property. Would we like to do that?
No, it's fine. I would track it out.
Okay.
I just thought on the key that you simplified it somewhere.
Yeah,
I might have just read it wrong.
Well, let's look at what I did, right? I don't ever remember what I did here. Oh, okay, yep. So yeah, that's what I did. And I turned it into that, which I guess is easier to deal with than what I had originally. That was clever of me to write that as a product rule only instead of a product and a chain, which was what it was before here. That's what I had forgotten during 5th hour when I did it. Yeah, that's a good idea, Mr. Kulik. So your question was this piece, right?
Yeah.
How I got to that?
Yeah.
Sine or tangent is sine over cosine. Cotangent is cosine over sine. So I made a common denominator, which is sine times cosine. So I had sine squared plus cosine squared over sine times cosine, which would be 1 over sine times cosine. I just did that all without showing anything, but that's all I did there.
Did you need to do that?
No, you could have done this with just the quotient rule and it would have been fine. I don't think it would have made it any easier to do what I did. Other than maybe like the simplified answer I got at the end had no fraction in it, which is maybe slightly better than what you'd get with the quotient rule, but like, it's not the end of the world. Who's next? Jack.
I just push with the answer for my time.
Mm-hmm.
So, in the answer he used took it a step further than what I did. I wrote it down, but I left it as 47 over 12 x 35 over 12 compared to 35 over 12. Is that a fine answer?
Yeah.
Okay.
Yeah, for sure. For sure. Again, as a review, the directions on the test are going to be one of 2 types. They'll be like, you're done when the calculus is done, or it'll be show that the derivative is equal to this.
Okay.
Where there I'm telling you what the stopping point is.
Okay. That makes sense.
Which one do you think there'll be more of?
First one.
The first ones, you're done when the calculus is done problems, right? I think I don't know, it's 2 or 3 show problems and that's it.
Sounds good.
Okay.
How do you think they stack up to the show problems in this review packet?
Easier than what I put in the review packet.
Cool.
Or on par with. They're certainly not like the ones that are like 12 gets terrible, right? 11 is pretty on par with what I would ask. I think that's a reasonable. 12 gets super messy, and I made a mistake even in it, so that I don't even have the right answers on here, which are very frustrating to myself. Like I tried to be so careful. I still made a mistake. Yuck. That's what I get for not wanting to take a whole sheet of paper to write it out. It's like, I don't need to show all my work. It's like, yes, you do, you dummy. Ugh. How's it going? What's next? Blake.
Do you think that you could do a walkthrough too on the review questions?
Oh, sure. This
Or,
guy,
like, you don't need to like actually like do the whole like mathing thing out. Just like
we can do the. We have lots of time.
variability.
We can do the whole mathing thing if you want to do that. That's fine.
Sure. If you want to. I'm just like a little bit. I don't know. Just something
So,
going on in there.
Yeah, when we look at this, what do we see rules-wise? You should see two chains, right? One for the cosine, one for the square root. Two quotients, one inside the cosine and one inside the square root, and a product. The two things are being multiplied together, right? Everybody's cool? Which one needs to be done first? And this was the problem that I think that a lot of us had on the quiz, right? You got into a complicated problem and really struggled to see what to do first. So let's kind of walk through this symbolically, at least on how we're going about doing this. Okay? So this is like, let's call this whole thing f of x or whatever. So I would go and take the derivative of both sides. To take the derivative of this, what is the outermost thing going on? Multiplication. Okay? So the product rule would be the first thing I need to do. So let's call this guy G and this piece H. So I'd have like G times H prime of x plus H times G prime of x. Does that feel okay? Now to do H prime, that's going to be a chain rule, right? So call K of x square root of x and J of x that quotient. And then similarly, to do G of x, that's another chain. Maybe we'll call L of x cosine, and then M of x will be that quotient. Does that feel okay? So if I do H prime, that's going to be K prime of J of x times J prime of x. And to do G of x, that's going to be L prime of G of x times, L prime of M of x, times M prime of x. Does that feel okay? And that's probably as far as I would go in terms of like symbolically representing this. Pat, I mean, you could give like a numerator and denominator function for the quotients, but now it's just kind of becoming a little bit of overkill, I think. So if we do this, what do we get here? So that stuff is all going to stay the same. So K prime is just going to be 1/2, and then to the negative 1/2. Everybody okay there? Then we have the derivative of 1 plus sine x over sine x, right? Do you need to use the quotient rule to do this? Mr. Kulik doesn't. He would think about this as 1 over sine x plus sine x over sine x, or cosecant plus 1. So I just need to take the derivative of that. Whoa!
That's crazy.
So that's just negative cosecant x times cotangent x. Didn't have to do the quotient rule on that. That's pretty sweet. That's a time saver. Now, if I had done the quotient rule on that, would it have been fine? Sure. But on a problem where it's a show problem, that's a lot of sorting out to do afterwards, but still doable, not incorrect. Okay, and then, so that's h of x, and then I have L prime. Okay, so the derivative of cosine is negative sine. And then my insides, was that 1 plus e to the x? Yeah. And then I have the derivative of that quotient there. But guess what? Mr. Kulik sees the same, can pull the same trick here. I'll just think about it that way. No quotient rule necessary there. It's a chain rule still, but like such a piddly little chain rule, right? That's almost a nothing burger of a chain rule. Right, the reciprocal is the same as a negative exponent. Yep, that was the trick I used there. And that feels pretty good to me. I mean, you could simplify this maybe a little bit more. I mean, the obvious thing is like, you know, you have two negatives there that can cancel out or whatever, but I don't think I would do a whole lot more than that. What you think there, Blake?
That makes sense.
Teeks?
Can you do the quotient rule to on the first one that you simplified, please?
The quotient rule on 1 plus sine x over sine x?
Yes.
Okay, so you have the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So if we simplify this down a bit, I'd have sine x cosine x minus cosine x minus sine x cosine x, because that negative sign is distributing through also, over sine squared x. Those guys cancel out. And then I'd have negative, we'll write it this way, 1 over sine x times cos x over sine x. So negative cosecant x cotangent x, which is exactly what I got the other way, just with a lot less labor. Everybody's okay there? Again, I just took the sine squared and wrote it as two separate pieces that are just multiplied together, right? So in general, guys, the more complicated the problem gets, I think the more helpful looking at it symbolically is, and making sure that you're kind of working from the outside in on these different, or these variable, or the derivatives, right? So the first thing you would have wanted to recognize is you have the product of two functions. Then when you do the product of those two functions, those are chains. And when you do the inner part of the chain, that's the quotient. So the quotient really becomes the last thing that we need to differentiate. Is that, I know it's tempting to want to work from the inside out, but we can't do that with calculus. Not without being like ridiculously careful and kind of things getting convoluted. I think it's much easier to just outside in. Okay. Luke?
So I'm looking at number 12.
On the other sheet?
Yeah, on the other sheet.
Mm-hmm.
Specifically A.
Mm-hmm. Oops, I wrote on the review sheet. That's okay. You guys can still pull the from the file if you needed a blank one. I'm mumbling to myself that this sheet, I didn't mean to write on this. I did anyways. If you wanted a clean one, you can always like click the icon and it'll open up a clean one for you if you need a clean one. You know what I mean? Sorry about that. Sometimes I just get carried away. Yes, so 12a. Great. So it's asking to find the second derivative evaluated at when x is 0, right? Before I even do that, I would probably go and figure out what the y is when x is 0, because I'm more often than not going to have to plug both of those in. So to solve this, I'll plug 0 in for x. And divide both sides by a negative. And you could take the natural log of both sides, or you can just recognize that e to the negative 1 is 1 over e. I know. I pointed out that there was mistakes on 12. So it shouldn't have been positive 1, it should be negative 1, and then like a bunch of stuff after that, it's all googlied up from it. Yeah, I know. Okay, so let's start doing the derivative now, because we know that goes with it. So we have x squared dy dx plus...
Pardon the interruption. Any seniors who need a picture retake, please come down to the library now. Any seniors, please come down to the library now for picture retakes.
2xy. And then I have e to the y dy dx equals 0. Everybody's cool with that? Here you could take that and get the dy dx by itself. So you could subtract the 2xy to the other side, factor off the dy dx, and then divide by the x squared minus e to the y. So that's the equation for the first derivative. Now, for your next step, you can either differentiate this, or you can differentiate here. Either is okay. My suspicion is, because of this being asked for later, I probably want to differentiate with this, because there's probably going to be a lot of cleanup after the quotient rule when I substitute in a fraction inside of that quotient rule. And I just assume not have to deal with that. Does that make sense to you guys?
Could you plug the negative 1 and 0 into the dy dx equation on the right? Then find it, and then plug it back in when you're doing the second derivative?
Once we've found the second derivative. yes, we'll be doing that, but not until we've gotten the second derivative can I plug the value in. Okay? So let's take, I'm going to differentiate this thing again to get the second derivatives to start showing up. So when I do the first piece, that's a product property. The derivative of dy dx is the second derivative. Bless you. And then the derivative of x squared is just 2x. The next piece is also a product rule. So the derivative of y is dy dx. And the derivative of x is just 1. And then the third piece I have there is also a product property. So derivative of e to the y is e to the y dy dx. So I have two of those dy dx's. And then the derivative of dy dx is just the second derivative. Okay. And now, Anise, is where I would start plugging things in. So if I plug in 0 and 1, I get 0 over 1 over negative 1 over e, so just 0. Is that okay? I didn't want to try to save some space. So this guy with the x squareds, anything with an x in it, when I plug that in, goes to 0, right? Because I'm, again, still plugging in those. Everybody's okay with that? So just the x stuff, I'm just going to cross off anything with an x in it. So what do I have here? I have negative 2, and then I have e to the negative 1, and then I have times 0, so all that stuff just cancels out. And then I have e to the negative 1 and the second derivative, right? So I'm going to add, let's just rewrite what I have. So that gives me this. I'm just going to, oh, shoot, little typo here. So this negative sign need to apply to everything, so that piece should be negative there. My apologies. So I'm going to add the 2 over and then multiply by negative e. So there's my answer there. Is that okay with everybody? Okay. And if I want part B now, I'm just going to take what I had before, and everywhere where I had the first derivative, I'm going to go ahead and make my substitution. Well, actually, what's up? Oh, the first one is the second derivative. Thank you. And notice there that those are the same thing, so I'm just going to go ahead and add them together rather than writing them as two separate things. And notice here I have first derivative times first derivative, so I'm just going to write as first derivative squared. So far, so good. All right. This stuff now that doesn't have a second derivative attached to it, I'm going to move over to the other side. Bless you. And then the stuff with the second derivative, I'm going to factor that off. So far, so good. I'm going to divide both sides, or really I'm going to think about it as multiplying by the reciprocal of x squared minus e to the y. And let's actually do this. I'm going to multiply that in there. And the same thing here.
Just a one, you forgot the square on the first derivative for the e to y. Or did you get rid of that?
The square on the first derivative.
Sorry, the negative e to the y first derivative of 2. Right?
Oh, thank you. Yes. Thank you. Good, good, good. So I don't want to do that. Well, I do, but I want to do it this way. Leave that as minus. Oops, that's down to the third. Okay. So far, so good. All right, all that's left now to do is make some common denominators. What do I have to multiply this thing by? X squared minus e to the y. What do I have to multiply this thing by? X squared e to the y squared. And then it's just a bunch of like crummy cleanup. And then this is going to be 4x squared y squared. So it's going to be minus 16 x to the third y squared. Then I have minus 2y times x squared minus e to the y squared. All over x squared minus e to the y to the third. I'll distribute that stuff through. And then if I FOIL this thing out, I get that. Think that looks right. Do you guys agree? And we just need to check to see if there's any like terms here. I don't think that there are, though. I think this might be as good as we might be able to do. Obviously, that doesn't match what I had written down, but that's because I made another mistake when I did the derivative before. So, like, this was a big problem here. So I goofed that piece up, and after that, everything else gets mucked up afterwards. So I think what we did there is correct. Rest assured, when I ask you to do something like this on the test, is it going to be this unbelievably complicated? No. That was like a 20-minute problem for me to do it the first time carefully. Not realistic for you, okay? But if you can kind of walk through the simplifying that we use there, it's just like, it's just a matter of keeping track of everything, right? But it should be, like, that should be doable, but just like far too time consuming to be worth doing, and the possibility of like multiple little trivial mistakes when you have the right idea, or there's a lot of possibility for that. Tegan?
Can you scroll to the left a little bit?
Oh boy. Yeah, sure.
Okay, when you got like the negative 4x and then the negative 2xy over x squared minus ey, why'd you square that?
So it's because this was squared, so I had to square the numerator.
Oh, okay.
Right? I squared the numerator and squared the denominator separately. I know, right? Like, that was an easy thing to miss. Anise.
I noticed like on the review, you tend to simplify before starting like the calc. Do you suggest that we do the same, or is it okay if we don't? If we just go straight into the calc?
So,
Like some of them, like for like 9 and like
yeah.
it would probably be smart to simplify before, but like for 4, I found it easier to like just go straight into the calc. Does it matter?
So the short answer is no. You can get the same answer doing both ways. The pickier answer is, if it's a show problem, oftentimes if you don't simplify first, you're left with like a pretty hellacious algebra problem at the end to try to like grind this down so it's going to look what it needs to look like. So it's a good habit to get in. In addition, like on 4, doing algebra beforehand doesn't make your life enormously easier. But on like number 9, it sure did.
Yeah.
Like number 9, that turns into a trivial calculus problem with a little bit of algebra, as opposed to doing like product and product is, then you have like chains and all kinds of nonsense in there if you don't see it as an algebra problem first.
Yeah.
Where that one becomes kind of a nightmare. And if that's a show problem where it's like, oh my God, you know, I have all these things I have to make sure are like terms and keep track of, and it becomes, it's a rough problem if you didn't do it algebraically the first way, or right away, just to turn it into a simple calculus problem. So I would say in general, the short answer is no, it doesn't matter. The long answer is you should get in the habit of trying to do that.
Okay.
Now, if you don't get all the algebra simplifying that you can, it's usually not that big of a deal if you've gone and done some of it. Oftentimes you can get halfway through and be like, yeah, okay, let me erase, and like I'm just going to go back and like, like I can tell the simplifying is going to be terrible here. Like, just let me erase back to here, do a little bit more, and the calculus was easy, and the simplified answer basically tumbles out at me, which is often preferable. Does that answer your question-ish?
Yes.
Jillian.
For number 11, when it says implicit differentiation, that just means we're finding the
You're still looking for dy dx.
okay. What's the difference? Like, how would we solve it, or how would we find the derivative in a non-implicit way with this one?
Okay, so all that when we say implicit differentiation, what that means is that the y needs to be treated as a variable, as opposed to a constant.
Okay.
So that's why the directions say implicit, is so that you don't say, oh, well, y is a constant, I'm just going to, treat it like a constant. And it's like, no, the y is also a variable.
Okay.
So when you see that implicit, that means that unless it's been stated as a constant in the direction, any letter is a variable. Does that feel okay? Okay. And again, we would do 11 much in the same way we did 12, right? What else?
Sorry for this interruption, but this is a last call for anyone that needs a picture retake. Please come down to the library. Last call for anyone that needs a picture retake.
I'll be
Please
back
come
in
down to the
15
library.
minutes, guys. I'm just joking. I don't care what my picture looks like. I don't even smile anymore.
Oh, that is so sad.
They're just like, smile. I'm like,
Not happening.
yeah, you might get a closed mouth smile out of me. You don't get any teeth anymore. It's been too long. Done this too many times. I'm glad you guys find that amusing. There's no reason this can't be fun, right?
How much do the album pictures really need? I mean, for us seniors, it literally does not matter in this place. It's on our little it's on this, and it's not going to be in the yearbook. It's never going to be seen again.
Yeah.
No, we have actual senior photos. Are you guys pictures are really right?
I don't know. It's been years since I've even opened the yearbook when they give it to me. It goes in the closet
Oh, okay.
with the rest of the collection. At some point, I'm probably just going to take the collection to Mr. Lillick and be like, I don't want these anymore. They're taking up too much space in my closet. What would you like to do with them? But they're there if you want to go back and look at a yearbook from 10 years ago.
Maybe I'll see my brother or my cousins or something.
Yeah, sure. What else do you guys want to talk about?
How are you doing?
I feel okay. I did my final revisions on the test yesterday, so I went and took a problem or two that I felt was like, this got too complicated, and found a way to make it a little easier. I was pretty proud of myself, and printed about 8 copies before I finally realized that I fixed all the mistakes that I had, or things that didn't work out quite as neatly as I wanted them to. So yeah, Teagues.
I forgot my tablet at home, so can you zoom in on that problem just so I can do this? Thanks.
Yeah, no problem. Amanda. Yeah, sure. So, we just start out by taking the derivative of both sides. Derivative of 2x cubed is just going to be 6x squared. This piece, though, needs a product rule. Does that feel okay? Okay. The stuff without the,
Is that a 6?
yeah,
Oh.
3 times 1. The 1 was from the derivative of x. That's just me trying to show my work.
Okay, yeah.
So the stuff without the dy dx, I'm going to subtract or add to the other side.
Why did you choose those terms to add to the other side?
Because I'm trying to get the dy dx by itself.
Oh, I see.
So the other stuff I'm going to factor the dy dx off of. Okay with that? So that's those guys, right? I'll divide both sides by that quantity. And then I notice that everything there has a factor of 3 in it, right? Each coefficient has a factor of 3, so I can reduce that. And that is exactly what we had before. Yeah. This is more what I would have in mind. Things working out on the test, more so than 12, which got like pretty terrible. And if you did it as a quotient rule on 12, it got even worse. So, Tegan.
Okay. So if we had that answer like times -1 because we like flip different things, could you just times it by -1 in the problem to get it? Or would that not make sense?
So what I think Tegan's saying is, what if I had this, right? What I would say then is you could just do that at the end to make things, to get the signs that you need. Since it tells you where to stop at, right?
Right.
Yeah, you can do that. You're just multiplying by 1. No problem. Right? But that was a hypothetical, right?
Yeah.
Mr. Kulik didn't do that in this problem because he wrote the problem and kind of knew where he was going. And this one wasn't so complicated as opposed to maybe some of the other ones.
Where did that negative in the denominator come from?
You're talking about this?
Yeah. And that's before that.
And that negative came from the original in the problem, or it was a subtraction. Luke, if I were going to take a guess, it'd be that is what you forgot.
Thanks. I think so.
It's really,
The same answer is just I honestly.
yeah.
Oh.
right? Really, this is -3 times the derivative of xy squared.
Yeah.
So that you have to distribute the -3 after you do the product rule there, which is probably, if I was going to take a guess as to where you made a mistake on the derivative.
Yeah, not distribute at all.
Yeah.
I distributed it into the first part of the product rule, but
And not the second.
part of the product.
Yeah. Yep, that would have been my guess as to what the mistake was, without looking at your paper, but because it's an easy one to make.
On the calculator, how do you put points into it and then have a graph? Is that possible?
Maybe. What do you?
Well, how do you plot points on the graph of this calculator?
Okay, so if I want to just plot a point, I press Stat, Edit, and then if I want like the point, -1, -1, or whatever, I just put 1 in L1 and 1 in L2. The X is in Y1 and the X in Y2. Like that. And then I press second Y equals and turn on one of the stat plots with L1 and L2 as my points. And if I graph, stop, whatever that mess is. So if I plot, there's the point that I would have. Now you are going to have a problem trying to plot this thing on your calculator
No, I was just
because it's implicitly defined. Your calculator can't handle that unless you tried to separate the y, and I wouldn't even know, Mr. Kulik wouldn't even have any idea of how to go about doing that.
I was just curious in general.
Because that looks inseparable to me. Because we have the y squared and the y cubed. And I don't know any clever factoring trick to get that to a single y. Because cubic factoring patterns I'm not particularly strong with, unless it's a perfect cube or a sum or difference of cubes, and this is neither. So I don't know what to do with this. But in general, you could, that's how you can plot a point. And again, on an AP exam, this screams of a kind of a question they would have you like find the tangent normals for, because you can't really just make your calculator do it. Like you can't even look at the picture and then graph your tangent, your normal or your tangent with respect to your graph to make sure it's in the right place, because it's implicitly defined. You know, like it's like, oh yeah, you can use your calculator for this. Not going to help you, is what they like to do. I'm just, again, my observations, I haven't done a million of these exams, but I've done a couple to just, before we started the course, just to kind of refresh myself about the kinds of things they like to ask and how they like to ask things. But this is a free response style question anyways. This would not be a multiple choice style question. Too much to do. I'm sorry, what? Yeah. So to get the slope, all I'm going to do is take my derivative and evaluate it at -1, 1. So what do I get there? I get 1 minus 2 over 7 minus 2. and then I just say y minus y1 equals m times x minus x1, and just simplify down a little bit. What's that? Negative 1/5 minus 1 is negative 6/5. And then I remember that the normal, or the slope of the normal, is just the negative reciprocal for the slope of the tangent. So I'm done. This is really the only calculus step in the whole thing. It's just remembering that the slope is the same thing as the derivative evaluated at that point, which we've hammered, I think, pretty good. If anybody remembers anything from the course so far, is that like the derivative is the same thing as the slope? Is probably it. Like that's a question that I would expect every single one of us to get correct. But the rest of that is like Algebra 1, right? Just writing the equation for a line. Yeah. Yeah, nothing sneaky, nothing complicated, right? It is as easy as it looks. This is a dunker. This is kind of what you call this question, is a dunker.
Up on the C, I just took that other equation and I just flipped the.
Yeah, doing it the hard way.
No. Well, like.
Yeah.
That's one way to say it.
Fadeaway floater there instead of just like. You know.
Yeah, no, I did that, but then I didn't recreate the equation, so I just took the old one and just swapped in the new slope. And I looked at it and I'm like, what did I do wrong?
You didn't.
Yep.
Yeah.
Yep.
You just did it wrong. What did you do? You wrote the equation for the line incorrectly. It'd be really weird to have two lines that are perpendicular that have the same y-intercept.
Yeah.
If it's not 0. If it was 0, I'd buy that. Like if it's, but otherwise that shouldn't happen, right?
And just to confirm, tangent is the actual, like it's the honest to God's like slope of the derivative, and then the normal is like the perpendicular.
Mm-hmm.
So.
Yeah. So like, you know, maybe our function is like some kind of weird ellipse or whatever. That would be like our tangent.
And then the normal is like just cross over the x.
Yep.
I messed up on the last test of that one. I did the something like that. So.
Mm-hmm.
Oh, did you end up ever posting the answers for those like 3 fun little differentiation problems at the very end? Yeah. Oh, they are? Oh, that's perfect.
That's this thing, right? Yeah. And again, I tried to give you some symbolic on those. But we can do some stuff if you guys want to do stuff. That's okay. This time is blocked off for you guys to, you know, to see what you need to.
Wait, what document was that one on that had the correct answers?
This one.
No. Come on, man. Holy crap. No, I went to like the middle school math competition with this class. We got blown up. Yeah.
You just did math drop.
Did math for like a day.
And none of us made it to the final. We got like pizza. And we skipped the day of middle school.
That sounds like a win all around.
Exactly. Yeah.
Okay, why is my graph like that? Straight from A.
Yeah. What's up, sir?
So, why does my graph look like that?
Because you're graphing over this little itty bitty tiny window.
Well, I just hit zoom and then, or zoom stat.
Let's do zoom. Well, zoom stat's going to just zoom in around your data point. Let's do zoom standard.
So Reed, did you go to that math competition too?
And you don't have anything else
No. Okay.
plotted, so it just.
I honestly do not. I don't remember any of this school day. I remember that like this. I remember that like in the final, like the questions was like a factorial problem, and I never heard of it in my life.
Yeah, we had a volunteer for that too.
Yeah.
What do we do? Honestly, can we have like a calculator class where we like figure this thing out? Because there's like so much stuff I have like no idea what any of it is. And I feel like it'd be helpful if I did.
Well,
Shut up, calculator class.
have we talked about how you can kind of try to check these derivatives with your calculator?
I want to know how to do everything.
Can't you just like do Frank Roth taught me well?
Actually, I have no idea.
So let's say you did number 1, right?
Yeah. Oh, projected that.
Oh, why did it do that? There it goes. So what you would do is you can take the original problem and just type it in exactly the way that it appears. And then you could take your answer that we get. So like 35 times square root 2 times x to the 5/2. Oops. Now I'm pretty sure I did that, times x to the 5/2.
Does a rabbit emu actually cost money? Is this like a
That was free.
really?
Mm-hmm.
Wow. Is it legal?
I think so. I think they just found it on the apps, the Google App Store or whatever, or the Microsoft App Store.
That's like, I mean, that's just a calculator.
Yeah.
These things were not cheap. I remember that.
Okay. So what I'm going to do is I'm going to do a little numeric test. So I press the math button, and I can do n derive. So I'm going to differentiate with respect to x. The original problem, which I typed into y1. So to get to the y1, we press vars over to y vars. We're in function mode. Pick y1. And then a value for x. I don't know. Let's just use 1. So that's my answer. What I want to do is I want to take my solution for the derivative, which we typed into y2, and I want to plug 1 into that and see if I get the same thing. That's a good sign. And you can check with as many values as you like. My suggestion is to stay away from which values? 0 would be, zeros are usually bad, right? Because oftentimes, even if you have the wrong thing, if you do plug zeros in, you just get 0.
Yeah.
And maybe I might be cautious about negatives, because if I have a square root or something in there, you can all of a sudden end up with undefined. So sometimes it's a little bit of a hassle to find something that works, but that's a decent check that you can make. That's a numeric check. I often would recommend checking more than one value, right? Just don't do one and then be, okay, that's good. But typically, unless you've stumbled into something kind of degenerate, if you get that on the first one, it's usually pretty good. Blake?
This is actually another calculator question. So I might have to come up.
Yeah.
So for some reason, my calculator has a y0 that I can't get rid of, at like the y level 41, and I'm not sure what I did to get that.
That is interesting. I don't think I've ever seen that. Oh, there it is.
Sorry.
Just down at the bottom.
Okay. I thought it was going to be like up top or something like that.
It was just 10. Sorry. Yeah, no, it's totally fine.
If you graph, like you do the dx and then like y1, that's your like original calculation.
Like,
and then
yeah,
you do when x equals x, what graph the derivative?
Let's see. I don't know that I've ever tried that, but we can try it. And let's turn this one off here as long as we're at it. No. And my suspicion is that it doesn't like, it doesn't like doing the derivative in there at all, huh? Doesn't look like it'll work.
All right.
Yes, sir.
I have a question on one of the review problems, one of the three.
Yeah.
For number 3, how did you simplify the derivative of that last derivative?
Okay, so you're grabbing one of these guys from down here, right? Okay.
So I got all of like the chain rule stuff, but like from the last one, I don't understand how you got from like the derivative of the first part to like the fact
Thank you.
of the x and the x e to the x over the x.
Katie, this is for you. Oh, okay. Let me look at this then, since it's like you're talking about a specific piece.
Yeah.
So you're confused on this part.
Yeah, because I got that first part of the step above it, but I'm not sure how you simplify it.
Okay, so this is the derivative of this piece, right? So what did we do there? We have the bottom times the derivative of the top. And then minus the top times the derivative of the bottom. So if I now FOIL all this stuff out, so I have a 1 times x e to the x, and then I have a e to the x, and I have an x squared e to the x, and then an x e to the x, and I have a minus x e to the x. So those guys will cancel out. And that's the numerator that I should have. Is that cool?
Yep.
No problem. Like?
You might do a walkthrough of number 8 on that review sheet.
Just like the wings. It's like, no, the best way, but you
My voice
just, you grab a pen to speak. Very like, get it.
All right.
Don't be offended.
All right. So when I look at this, what do we see?
I did like a product rule and then like with the product rule inside.
Okay. Do you remember the shortcut for that?
There probably is one. I honestly can't remember.
Oh. This guy's not wrong. It's a shortcut.
Oh, okay. So you have all you multiply them all together and then you have one of each.
Yep.
Okay, I can remember that.
Yep. And then that works if you have 5 things multiplied together, or 25 things, or 100 things. Right? Now, you could do this as like one product rule inside of the other, but you'll end up at the same spot. That's a nice...
And that helps when you have like huge...
Especially when you have stuff inside of, like we have chains inside of these derivatives.
I've been working on it.
Right.
It took me a long time.
So
I subbed in the fraction one too, not the.
yeah, that makes life a little harder, huh?
It's not right. It's pretty close. It would be like a 5.5 out of 6 because you'd be like, he was so close. He just,
Yeah.
not really good at adding numbers.
Look, some of the easiest stuff is the stuff that you make the mistakes on, because you just get kind of
Once you get like four
careless about or whatever. That's the chain rule.
Oh.
Oh, not 2x though, just 2. Thank you. So there. Right, so this is...
Oh, it's that, yeah, okay, it's that law.
Yeah. Like you may just see like
Does that feel okay? Yeah, and I think we went through that shortcut when we did the product rule in class, but based on the homework quiz, nobody really remembered it. That's why I put it in here again for you guys. Again, that's super helpful to just go straight to that. And if you're not sure, you do it as a product inside of a product, right? You just treat like the first 2 things as,
as one whole variable. That's what I was going to do.
Yeah, you can do it that way.
It's just easier.
It is much
It's
easier.
to remember.
Yeah. And if you forget, if you're not sure, you can always go back and do that. But like, it's easy enough to remember.
Yeah.
And it's a nice one. It's a big time saver if you remember that, because boy, that's a lot quicker than grinding through a product inside of a product, even if you're doing it all symbolically.
Huh.
No problem. Sure.
I just how did you?
And even if it's not perfect, Paul, like that's enormously instructive doing that, right?
That's what I figured out.
Like even if it's not perfect, like the one on the test isn't going to be that complicated. and just getting reacquainted with like all those algebra rules that are.
I had to use photo math to remember my I'm like, what's the next step here? And it's like, oh, do this.
Okay. Yeah, Teeks.
I was wondering if you had like an extra copy of the homework quiz that I could like use to study.
I would, except not everybody's
No,
taken
yeah.
it, which is the.
I meant to take it this morning, but you have to get to the testing room like at the start of the testing room. You can go in after they've already started. That's what they said.
Oh,
So,
I didn't.
I have a study hall tomorrow morning, so I'll do it tomorrow. Yeah,
Okay.
that's big. Yeah, no, that's
Jillian's not the only one,
Oh, yeah.
so take that.
Wait,
I think
what's the other one?
Sophia Keolin hasn't done it yet either.
Oh, names. Europe.
So she's in the other section. But how's you guys feel better after having a long week to kind of work stuff out?
Yeah.
Really get some good practice time in and slow down a little bit.
Yeah.
At least like everything else, life slows down a little bit.
Never. Over the weekend in calc and physics, I'm like at another level of Isaac Newton. He's like below me.
Good. I'm hoping that you guys do very well. Right? Sometimes you just need some time, right? So just like, I just need to spend some time on this and really practice and grind through some tough problems on my own. And Paul, what's up? Sure. Like I think that we're all eminently capable of doing well, right? And just a question of spending enough time and like working on something and not giving up until you've actually got the correct, the correct piece to come out of it. Yeah, I mean, to be quite honest with you, like you're never going to learn anything as well as the stuff that you figure out for yourself. Like something that you learn by figuring it out yourself is like, that's locked in. You're never going to have a problem with that again. As opposed to like, oh yeah, that's the answer key, showed me how to do it. You know what I mean? But in general, like mathematics is a discipline is like an exercise in, I don't know, what do I want to say, like resilience. Like if you're just willing to keep grinding, like that tends to pay off pretty heavily, and some people that don't need like some of us get to a point, it takes a long time to get to a point where we really need a lot of grind time. And some of us are like, yeah, that's just my life. So I have a lot of grind time on this. That's okay. But eventually everybody gets to the point where it's like, yeah, this just isn't easy anymore. It just takes a long time to kind of like sit down and really kind of think about it and work through the details. You know what I mean? And once you get good at it, like the details aren't as big of a problem. Like you've seen the way that I do some of these problems and how quick it is. But again, this is like Mr. Kulik has been doing like being a math teacher for 15 years, has a all but dissertation PhD in mathematics. Like there's thousands and thousands of hours of practice that you see is why it looks fast and easy, particularly the algebra stuff, where it's like I've been doing high school simplification for 15 years, like all that kind of stuff that's like can get a little fuzzy for you guys. It's just like it's kind of instant and easy for me, and it's not because Mr. Kulik's so much smarter than you. I mean, he is, but it's more a product of the time spent doing it and practicing it, Like just imagine if you took the same class for 10 years. Every year you did the same thing. And you were no longer evaluated on like getting things right or wrong, but you were presenting to someone else and showing them how to do it every day, sometimes multiple times a day, for 10 years. How good would you be at that? You'd be really good at it, right? You'd be really, really good. And that's what you see when like you watch your math teacher do something and you see a product of thousands and thousands of hours practicing this. And that's why it's like often flawless and looks so fast and easy. You know? It's like if you watch somebody in like a professional musician playing a musical instrument, like they pick up something and it's like, oh yeah, listen to it and then just pick up their instrument and play it. Like it's instant. And it just looks so easy and effortless. It's like, well, you don't see the 10,000 hours that I've spent like playing and practicing and listening to music so I can do this. It's not, you know, it wasn't an accident. And maybe I had some natural talent to get me started, but you don't get to that level of being a professional at anything without, you know, a lot of practice. Yeah, it took thousands and thousands of years. Maybe not thousands, hundreds anyways.
So,
Depending on when you decide Rome fell, right? Well, that's a hot question. Do you consider like the Eastern Roman Empire still the Roman Empire?
Mr. Cool,
Yes.
sorry to interrupt.
No, you're fine. Interrupt.
So, if the natural, for number 6 specifically,
Sure.
so without doing, without simplifying or anything, the natural log of that would just be 1 over that whole thing.
Yes. Times the derivative of the whole thing.
Yeah, but I loved how number 5 was like that. I was like, let's go. You know, I didn't have to do it again. Appreciated that a lot.
I also put it on there because this, if you see this straight from jump, is just really 3 easy chain rules, not linked chain rules, because you can use your just 2. You can just use your properties of logs to like build this out into like the difference of 2 logs that are just like quick chain rules. There's no quotient. There's no chain inside of the, around the quotient. It's just, you're welcome. Sure thing, guy.
So I have to do like the self.
I just double check for number 10 on that review on this. I don't know. There's like a lot of like the natural log of 4x is going to be 1 over x times 4, and then that'll cancel.
1 over 4x times 4. Yes.
And then that'll cancel. Okay.
Correct.
Thank you.
You're welcome.
Yeah, I know.